Hi, everyone, and thank you for getting back to the machine learning track. I didn't have a chance to present myself before, so my name is Noah Lubin. I'm a data team lead at Diagnostic Robotics. And now we have a very special lecture who will be given by Eric Aquaronne, leader of enterprise AI at IBM. And he's going to talk about AI entering mission critical business applications, challenges, and IBM hardware strategy to cater with client needs. So, Erica, the stage is yours.
Thank you. So, hello everyone. I don't know how many people are connected. It's like a mystery in this application, but my purpose is to explain you what we do in IBM on enterprise AI. So, AI for the clients who have existing applications, and so you understand what we do, how we do it. And so, let me share my screen with you. And now you won't see my beautiful face, but you only see my screen, which is much better. So you should see my screen and the crazy thing, and now I'm going to swiftly move to a presentation deck. So hopefully you can see my deck. So can you see it? Anybody can confirm you see something? Okay, so the idea is, what do we do? I would start with a little bit of, how can I say, a state of the art. So everybody talks about AI a lot. What you don't know is that mission critical application at clients, so what we call enterprise, and this can be in many domains. IBM is in many domains, banking, finance, insurance, trading, and also industrial domains. They already use AI tools for quite some time. AI is a vast domain, and I'm not going to give you a lecture on AI, but business automation AI tools are in those 5 sectors, and they are very present. Every time you pay with your credit card, there is I think a 97% chance that your transaction is going to be checked by an AI software running on an IBM system, an AI software developed by IBM, sold by IBM since 15 years minimum. That's going to check, is this a fraud or not? And maybe deny your transaction if it's assuming it's a fraud because you just bought something in Israel and then the transaction is coming from Thailand 2 minutes later. So the evolution at the clients is really, they are moving from existing tools to new type of AI that are typically machine learning, a little bit of deep learning, but essentially machine learning type tools. So data trained AI. And when you look at this from the client point of view, we see 2 big constraints. First constraint is, where's the data? We call that data gravity. But essentially, if you want to use AI in business, well, you have a business system that are actually, manipulating transactions and doing the stuff for the business. You have to do it at that point. You can do it in batch. You can do it separately. You can do it for studying separately. But when you come to business, you have to actually be able to do it at the time you're doing business transaction. And so you need to embed that AI in a place where you can actually use it in transactions. So in IBM, we have a view of, trying to help our clients. Client has always been, our number one preoccupation. And we have I would say, a holistic approach into where we put this. And there are 3 big things we are trying to do. First, we want to make sure that clients can actually get AI into their existing mission critical applications. So, it's not like replace everything like tabula rasa, but how do you add this into what's already running? We want to make sure they have an end-to-end data pipeline. So something that actually allows the client to be able to manipulate the data for those new type of AI where you require a lot of data and do it in a proper way. So what are tools for this? And then there is a big elephant in the room. I think I should have put it in the top of my chart, especially today with all what's happening in our planet. Security, trust and compliance are very, very important. So we have highly developed security systems. I will come back onto our systems later, but it's really like today the number one when we talk to clients. Make sure that whatever we change, whatever we add, we don't break the security and the safety of our systems. So and this is to be done in our today's infrastructure. So there's no more like everything is on-prem. Today everything is everywhere. So we call that hybrid cloud, but essentially it's like your data can be in multiple places. Clients are not anymore working on only like buy something. They want to have a consumption models that fit cloud models, whatever they consume. And then they also are now asking the infrastructure to be quite intelligent. This is to be like self healing sometime, and then it's not anymore like an IBM only play, and it's never been. It's a very large play with open source and many players. So make sure you fit in this environment. So let me check time. Yes. So if you look at AI and you look at this from I would say a very simplified point of view on what you want to do, where are things, essentially to be efficient, you want to have a good data layer, because that statistical AI requires a lot of data, and you need to make sure you actually able to manipulate that for training and for the inferencing, and it may come from different places. So that's the bottom layer. Then there are a lot of development happening anywhere on AI. I mean, people do AI on any cloud, and that includes clouds with IBM systems like Power VS, which is IBM Power Systems on the IBM cloud, or on other clouds. IBM has hardware on different clouds. There are many third parties. And then we have this block, which we call the mission critical workloads, where we have our clients. We have two main systems in IBM, two main families. We have the Z family, which is also known under Linux One, when it's a Linux only Z system that's not using, I would say, the existing other operating systems. There is a Power family, and both those systems are available on-prem, on the cloud. So clients have application in both those places, and we have them in the IBM cloud, non-IBM cloud for Power, only on IBM cloud for Z, where they provide those very secure hyper protect services where not even the operator of the system can see what's happening. So they are highly secure, and they are required by our clients. And then on top of this, you go back, you have all the environment to make this work. So in IBM, we are very focused on Red Hat, OpenShift. So the family of tools for this is in a box called Cloud Pak for Data. We also have Spectrum Computing, which is very utilized into also high performance computing for distributing workloads. And then you go one layer, you have all the very famous tools like Tensor, Onyx, Keras, PyTorch. So this is what we call the layer cake and all the building blocks. But you see, we have elements in all the layers in IBM. I'm part of the system, community. So we do hardware, so we do storage, we do software for storage, we do systems, so computers, and the software that go on the computers. And then we have a full team on cloud software. I mean, any kind of software, and they do the Cloud Pak, they do OpenShift on Red Hat, and all those tools like Spectrum Computing, and this PSS is also an IBM piece. So that's the way it's structured. Now, if you look at it from a usage point of view, it's a continuum, but essentially there are three sections when you look at doing real-time transactions. So at the time they happen, and if you start at the right of the page, that's what we call analytics or big data, and this is place where people do AI on big stack of data. There is no, I would say, sensitive to time data, or no fixed batch window to operate. This is where you have all the machine learning, the people that work on data, like the data scientists typically do a lot of their work on this right side. When you move to the middle, you start to enter an area where your application on AI on the data is actually only good for a certain time, because your data is only valid for a certain time. So if you go in retail and you look at the transactions in the store in the morning, and you want to plan what's going to be on the screen for the afternoon, you will have to analyze the data, and that data is only valid for a certain time. So you start having a little bit of I would say, time requirement or SLA type requirement, they are not so strong. And then you go into transactions. So this is where you're actually performing a transaction, and that's the left side. And that's where our clients are telling us, okay, we need to be able to perform that whatever AI task in a very short time. We have a couple of milliseconds before we can be done, and this is what we call real-time transactions. And we have a lot of things happening in there for finance, insurance, healthcare, and there are other domains, but that's where we think we need to fix first and make sure we are very efficient and provide our clients the value they're asking for. Because if we fix that left side, well, the right side is going to be okay most of the time, because the I would say the requirements are lower. So when you look at how we look at addressing real-time transaction doing AI, so we already do the type of AI that existed for a long time, so all the symbolic AI, and now we're talking statistical AI. There are a lot of problems when you want to do this, and I try to simplify into one page the type of approaches that are possible. So first, let's look at the problem. And this is not something invented. This is very close to the reality. So you're talking hundreds of thousands transactions per second or more. You are looking at roughly a couple of milliseconds latency, because there is an SLA, a service level agreement, that the client needs to respect. And this is typically based on client need. You are the cashier, you're paying. You're not expecting to wait for 2 minutes before your card transaction is approved. And they view adding AI to their existing processes today, adding I would say statistical AI as a differentiator. So they perceive this is going to be so good value for our clients that it's important when to do it. So that's the requirement. And now when you go from there are two very well-known generic approaches. The first one is, well, you call somewhere and you go off platform, and you have an engine that's going to do inference on your AI and score your transaction for whatever scoring you want to do. Maybe it's it's that loan request done online, a loan request that we should agree to. Is the guy has a chance to, is the client a default risk or not? So when you do this, there is a first problem, is it's very difficult to scale this. If we're talking 100K transaction per second, this is actually very difficult to scale. And one of the reasons it's difficult to scale is because the latency between your main application, your AI location, and then coming back, you're talking 50 millisecond latency, easy. So it's very slow. So it's not like instantaneous from the end user point of view. So that works. If you want to respect a very stringent SLA, you cannot. The only thing you can do practically is only instead of doing AI on every transaction, is taking a sample. And that's not what typically people would like to have. So that's the first approach. And the second approach is you put a GPU in your machine and you compute on the machine. So you have a GPU on the card, on the PCI, on all your machines. So you start building what my friends call sometimes Frankenstein machine. So you start putting a lot of stuff in there. So you actually decrease the MTBF of the machine. And when you do this, you actually increase your scaling. So you can actually scale. But the latency is very hard to take below 10 milliseconds, because you still have to go through all the PCI process. So you are better, but you're still not into the millisecond range. And so that's where come the approach that we've been studying for some years, and we are now deploying into our system since last year. It's to put the inference in the CPU by making sure the CPU has what I would call some specific enhancements to be able to do it inside without needing to go outside. So if you do it in the CPU, and the CPU has the the right characteristics, you actually doing everything at one place. You have the data next to it. You make the latency and you make the scale. So now I'm going to show you how we're looking at this, what we're doing. I'm not going to bits and bytes and hardware and copper details, but so you understand where we go before we talk about the next thing, which is it's very nice to have the hardware, but you need also to have all the software that go with it. So what we have decided to do is to optimize for AI our silicon, so our processors. And you see the dates are not like very, very recent. I mean, the P10 processor unveiled 2020, so this is the announcement, and shipping in August 2021. First machines kind of reached the client in November last year, so it's very fresh. That's for the power machines, so one kind of machine. And for the Z brand, we unveiled a chip in August last year, and the chip is shipping since this year. Probably around the summer. So we just get the machines sent to the clients right now. And the idea is have the AI in-core solution. So we can do everything concurrently, the regular transaction and the AI, do it in the same thread, and make sure we are optimizing the system. So we're not saying we're going to address every case. Okay, it's not like this is not a replacement for GPUs, clearly. But that's a way to make sure we can do in-core machine learning and AI, and we can do it faster than a regular CPU and faster than a CPU with either closed GPUs or GPU remotely, so we can fit into our clients' requirements. And when you look at the client's usage, actually what you find is that most clients are using machine learning. They don't use deep learning. I mean, deep learning, yeah, it's used for voice and image. Typically, machine learning is excellent for the rest in normal business. And so, make sure that this works fast and good on those systems. And also, we decided not to be able to do everything to everyone. We have actually selected clients, work with them, and we have embedded into the silicon, capability for specific, type of data that we know they're going to use. Because, you can be everything to everyone. So now, in terms of, you understand, we have two families of chips, and what we're doing is we're typically shipping one machine. So last year we shipped Power. This year we shipped Z. P11 is being designed. So what we have currently at hand is P10. And so we actually have a plan to work on those. So right now we are in the first, what we call a AI core family number one. We have 4 generations plans for this. So essentially, we are putting accelerators next to the CPUs, in the CPUs next to the cores, to make sure that we can go much faster for all matrix computation. And so again, this is not going to address everything, but we now have the first results at clients, and it works very, very well. And so we are now like second generation in the family one. P1, P11 will be the next one, and we have a plan to going further. So every new family of chip is going to bring that accelerators. And if you want more details of accelerators, I think this is worth like probably a couple of hours discussion, or at least a specific presentation. Then we have a plan for the next phase of those chips with accelerators. And we think that, from this 10 times to 50 times acceleration, we're going to go much faster. And we think about the next generation will be cell-based type systems, but this is research at the point. So essentially, the points where we are now, we are deploying those chips, and they're actually proving that they are delivering what we expected. So we go fast, much faster than the rest. So enough with the hardware, because I wanted to cover the stack of software that use it. This is one of the things I'm working a lot on, because first you need to make sure you can exploit the hardware. So let me give you a little view of how we see the exploitation. So the idea is very simple. We have symbolic AI on our system for a long time. Now, this is the growth of all the statistic AI. How do you make sure you bring to the AI solutions the value of the CPUs? So our CPUs bring acceleration, There is something I didn't mention, but this is very key to our system. We have a huge parallelism. Our system are able by hardware just to go to 8 parallel tracks, and then you can configure them to actually stack parallel loads of software in the memory, because we have a large memory. So this actually also helps into the performance. And so to be able to actually use this, knowing that people do AI on many kind of tools everywhere, and that's the left side. And then we have our existing client that use, everything like they've been using for a long time, like Java, COBOL, C, C++, and they use Apache, the Apache. They use many things that are very stable and known for a long time, like Oracle database, HANA, SAP, the list is long, and we support a bunch of operating systems. How do you make sure that you can get those AI development that are very recent into those existing platforms? So we decided to be very flexible. First, we have built into our system, capability to actually import Onyx models. So Onyx is an open neural network model exchange format that was created by, I think it was created by Microsoft. It was open sourced. So we have an Onyx runtime on our system. So you can take any AI from anywhere. At the end of your, training, if you want, you just export it, and you can import it into the machine, and the machine will run it. So you can call it. It's very simple. We also want people to be able to use, the regular, community runtimes for all the tools in AI, including Tensor, PyTorch. But there are so many others. So we have worked with a couple of people to make sure those things are available to the users. We also have even some custom, machine learning tools like IBM Snap ML, which is coming from research. It's a product, and this is all available on those systems. So today, there's absolutely no problem to take any AI solution wherever it's been designed, or you can design it on IBM Z and IBM Power for sure, and deploy it, or import it, perfect it on IBM systems. So really, it's really pick the technology you use, and we know data scientists have their own specifics, and then make sure you can augment your existing application with AI on the IBM system that you use today, or you will use when you see the performance of the system. So now I wanted to show you something interesting, which is, how do we build that, software stack specifically for the Linux domain, which is a very active one. And so you understand how we are working, and add one element to this, which is, how do we support client for this? So it's a very complex drawing, but essentially, and this has been a little bit tuned for Power, because I was using this for my Power client. So if you look at the bottom, every software is coming from the community. There are some big companies that are providing software, but let's say everything goes to open source community. If you look at the top, who are the consumers of those AI solutions? They are, the regular IBM consumers, people in IBM who are developing software. And then we have the external customer, all the clients, the partners, they want to use the AI software. So what we do is, and I will go from the left, I don't know if we can see my pointer, but I will go from the left to the right. So first, we look at the open source libraries, and we have a team that's looking at them on a performance point of view, and they say, okay, how do you make sure that this library is going to correctly use the in-CPU accelerators? And we have 4 accelerators per core, so it's a lot. Correctly, transparently, when they use NumPy, PyTorch, Onyx, whatever. So that team is looking at the open source code, and they will work with open source to upstream modification if they need to be. And that's the first piece. Then second piece is, how do you build this? So there is an open source project called OpenC. C is for cognitive environment. So this is an open source project, and we use that project to build the recipes, all the build environment. And inside IBM, what we do, we actually do the build, we do the binaries, we test them, and we have an internal IBM repo, and every IBM product, whether it runs on Intel, on Power, or Z system, which we also call S390, any product will pull the binaries from that repository. So we actually internally built all what we need, except Python. Python we take from Anaconda. So that's the big, arrow on the side. But that's what goes into our product. So we make sure we have like a stable set of binaries and the right libraries, and everything performs to expectation. So that's the internal view. And for the outside, what we have done is, you have Anaconda who's building Python and building different things. There are a lot of academics that started building OpenSea for their internal use, and they build it on all kinds of distros, OS like Ubuntu and etc. And what we have is we work with a company called Rocket Software, and what they add to the mix is they actually are building the same way we build inside IBM. And so they provide an OpenSea build that contains all those frameworks and libraries to our specs, but this is done outside of IBM. And something very important for our clients, they actually provide enterprise support. So Rocket C is able to provide support for the open source, and which is a strong requirement for our enterprise clients. So the clients can use, any academic build like MIT, USO. They can use builds from Anaconda, but if they use Rocket, they not only have the same build that we have internally, build the same way, but they also have all the support they need for being able to be very stable. Because again, those are production deployments. It is not test. So the clients who are deploying AI in production on very serious application, they are very strong on support, reliability, and those kind of subjects. So that's why we work with Rocket. So just to give you an idea on how we build software. Now, when you look out of this and you look at, okay, what do people deploy? There's something very interesting. There are actually different kinds of deployments. So let me show you now a drawing. So this is a typical, CI/CD machine learning operations flow from the problem to monitoring the solution. And there are two layers on that chart. So the bottom layer is really, why do you put your stuff on? So typically, what we see, we have our IBM system like Power System, and this system are IBM storage system, and I will come back to storage later. And then they put, Red Hat, typically, Linux. They need a container system, so it can be Kubernetes, or it can be OpenShift from Red Hat, which are equivalent with different features. And on top of this, you see two families of clients. They are the clients that want a totally integrated solution, and typically those clients, and they are the top, where you see the blue balls, they will look for integrated solutions, and what we provide for them for this is what we call IBM Cloud Pak for Data. So it's actually a preset of containerized software that contains everything from data collection to monitoring. So it's called Watson Catalog, Watson Studio, Watson Pipelines, Watson Machine Learning, Watson OpenScale. I mean, Watson being the brand name, and then there are components under it. So we can provide to clients the full integrated solution. And then there are clients who are actually very trained, that have a significant team of data scientists, and they're able to manipulate the low-level things. And I used to work with open source, so those clients, they actually use the Onyx, Kubeflow, and so this is a different family of clients that actually do the implementation together. They build it themselves. They are happy to use Kubeflow and Kafka, Trino, Spark. I mean, I gave you a little list of the tools that are typical. So, and those typically they will use the Rocket C build that I was showing you with the support, because they want to make sure they do this themselves, but they want to make sure the software actually leverage the machine to the maximum performance, and they want to have support. And when they graduate to a bigger configuration, typically they will move to things like Cloud Pak for Data, which also contains OpenSea. So all the open source tool built to the best performance of the system. So this is typically the layers we see. There is another thing I didn't put on that chart, but some clients are looking for no-code AI, and so I didn't put it on that chart, but we're actually working with companies that provide no-code AI. so they can leverage our systems also, because their code leverage the right libraries, and the right libraries have been optimized on our systems. So there is also the no code AI family in that, but this is already a lot on that picture. And the way we address that, that middle section, and what should you use, because there are different level of complexity of things, is it's very simple. So we looked, and that's the blue table at the top. We look at what our clients actually doing. So we call the clients, we say, okay, what where do you want to put your AI? And we found there were like 5 big categories. So there are clients that want to, they use traditional DBs, they use Java, and they want to add AI in this. There are clients that are already doing AI, and they want to, make it better. Like typically, my inference is not fast enough. How can I optimize? And so that's one family. There are clients that are very much into the multi-cloud domain, and they say, okay, I want to be a little bit agnostic. I want to be able to run things in different places. And so they are looking at Onyx, typically for doing interoperability of models. Then there is the family of clients, that's the fourth one, that are very advanced. Typically, those guys have a lot of skills. They are into we know open source tools, we want to use them. Maybe we graduate to some, Cloud Pak for Data, OpenShift type things, but we know what we do. And so this is typically, the most skilled client family. And then there is a last item on the right, which is all the HPC. So academics, research, defense, all those guys doing a strong HPC that we deal with. So what we have done for those big 5 categories, and I told you we are not looking at fixing the universe. We're just a small company, and we want to make sure we do well in the domains we decide to serve. We are making sure that for all those segments, ready for our teams and the partners and the clients, we can tell them, okay, this is how we think you could implement things, and you got 3 drawings there to explain use case, and we tell them, okay, this is the minimum hardware you need, this is the software you need, license and open source. This is how our client engineering team, our pre-sales team can help you in defining the solution, depending on where you start. Some people start with a lot of things. Some people start with I just want to do it, and they need to be helped. We have what we call lab services, which are high-end services. So this is not the typical IBM services. This is services coming from the labs, and they can help into deployment, very pointed, super high-level guys, about, I think there are 1,000 on the planet, so they fly all over the place to help do this. And we have the support behind it. So I was talking to you about the open source support from Rocket, so that's part of it. And there was also the traditional IBM support. So that's the way we look at this. And I'm about done. It's about time. So I'd like to spend a couple of minutes just a little bit on storage, because I think it's a very important thing that many people are not aware of. So if you look at your AI data pipeline, and that's a drawing in front of you here, they are very known, very famous, I would say, things you have to do. And what you may not know is that actually we have a family of products that address this, that have been there for quite some time. This is used in many places, like big research centers, to big banks, to industry companies, to make sure that initially they could have the data accessible from different places to do different things, which is exactly what is done for AI. So we have a family of software products that sit on IBM and non-IBM storage, but I will recommend IBM storage. It's much faster and cheaper. And it's called Spectrum, but we have all the elements to fit the data pipeline. So we have Scale that can actually, grasp data from different places, make it available where it's needed. We have Object Storage. We have Discover that allows to classify data, and Archive. So we have all the archive, so all the resiliency tools also in there. So the Spectrum family with Scale, ESS, Object Storage is also a set of tools that apply very well to AI usage. Well, I'm looking at the time, and it's about time, so I'm done. And Zivil told me we would be able to take some questions, so I'm going to stop sharing my screen. And then if I find how to stop sharing your screen on that wonderful application, and I'm back. Hello, Noah.
Hello.
So
So
I hope, Noah, you've learned quite a bit.
I did.
Uh,
It's super interesting.
I expected very few people know IBM has been in the AI domain for a long time. Okay, like very few people know that Linux is there because IBM actually gave patents, so Microsoft couldn't tank Linux a few years ago, like 15 years, or maybe 20 years ago it was. So we've been in the Linux domain for a long time, so it's natural that we have been, involved in AI for quite some time.
Yeah, so it was very interesting and I've learned a lot. We have a few questions from the audience. So Stevens asked, he says in IBM Redbook 2021, you have mentioned infuse AI into their application to automate repetitive tasks. He asked if is that what AI really is being really?
Okay, so yeah, I have not spoken about what AI is, okay, in that presentation because I assume that people were very fluent into what is symbolic AI, statistical AI, and big data, and all those rule set systems. So AI is a name for at least 15 different technologies, and they are evolving. Okay, some are not new. I mean, symbolic AI when I was at school a long time ago, Noah, I had classes on symbolic AI. At the time, it was very strange languages that are dead now. So there are different what I don't know what is Red Book, so it's very hard for me to comment on the Red Book, not knowing it. Give me a call, contact me, and Stevens. I'm very happy to have a discussion with you, explain you. But I think it's very important that if you've not done it before rereading what I presented, you learn all the technology in AI and where they apply into I would say a problem because typically when I meet people, they know what they're doing there. And my first question, okay, what framework, what models are you using? Because as I told you, we don't try to be anything to anybody. You probably understood that because we have accelerators in our machines in the CPU, we are not fitting a GPU into the CPU. I mean, this, from an electricity power point of view, it's nonsense. We try to be a lower per compute value. Before any energy crisis, this was an objective for us. So we know we are super excellent in machine learning, and we kill everybody on speed. Okay, it's not a secret. Our clients know it. Ask a client. It's very simple. Don't ask me. Ask a client. But it depends on what you do. So first question is learn what is AI, understand how it applies to your problem, and then we can discuss more on how can help you. But when you say CI/CD improvement or CI/CD, I think you've read the Red Book, which is how we apply AI to machine learning operations, which is a set of tools which is in the Watson family. So when I was showing the big bar with all the steps and Cloud for data, this is in there. Uh, and But I think we should have a discussion to make sure I show you what I know about AI, and then you get comfortable about knowing where to apply pieces of AI, because it's not like I put AI on something. This is nonsense. It's I have a problem, and is there an AI technique, a framework, or whatever that could apply to my problem? Data, rules, optimization, because there are those three big segments that fits it. And again, don't be influenced by the hype. If you look at the magazine, they only talk about deep learning. The journalists are focused on deep learning. Well, if you look at the reality, deep learning is this, and machine learning is the rest of the universe. So that's why I told you, we are not trying to be everything to everyone. You want to do deep learning, you're gonna have to buy a bunch of GPUs, and they are very expensive. But that's not what our clients are asking. They're asking machine learning, and they say this is everything for me because I want to plan, what I buy or whatever, they do with it. And that's where we focus because, we cannot be everything to everyone. That's just a fact of life. I see there is
Yes,
another
the
question.
industry is very different than the academia when it comes to machine learning. So
But
Maria
I deal with, I'm on the call with academics, with MIT, USU, and others every week. So we work with them because, if you look at AI in a life cycle point of view, academics provide the new stuff. They are very important, and then this slowly infuses. And but what gets into the business is there is a delay. And what I was telling you is what we're seeing is that now we go, we had uh, expert system, rule-based system, symbolically for quite so many years. We have optimization systems, all those, AI family in production system for quite so many years. This is today, this is the way optimization software for a year is planning, your teams on the planes, the pilot and different people. This is normal business. And now what we are seeing is that they are starting to want to add statistical AI, so machine learning trained by data into their applications. That's what's coming. And yes, they're also doing deep learning for, like, when you call your bank says, I want to do this, typically you talk to a robot, that. So they need an LP, which is deep learning type things. And there people are using also deep learning for vision, but this is different domains. And, again, we're not going to be everything to everyone. We try to be the best we can.
So we have
And
a question
and
from
then, and then yeah, there's an interesting question. So yes, the banks are many, many, many millions of code are still in COBOL. So we are able to bridge from a COBOL application to a COBOL business logic can call into an AI inside the mainframe using the same data and do an inference and respond to with let's say an assessment or a categorization done by AI. We do this.
So thank you very
So
much.
you don't need to kill your COBOL, and actually they don't want to do it. But you use your COBOL and you bring AI next to it, and you call into the AI and you come back. That's what is being done.
Thank you so much. There are no more questions. So thank you again for the great lecture.
So again, if you're interested, Noah or the audience, you got my name. Find me on LinkedIn, call me, and I'm very glad to help you understand this, because a lot of education is being lost into the media coverage. And c'est la vie. It's good because people speak about it. It's a little bit annoying because sometimes people don't understand what they speak about. But c'est la vie. Journalists are journalists and scientists are scientists, and then we are doing IT for enterprise, and so we are somewhere in that continuum, and we make sure our clients can actually do their business. That's our job.